Hi, everyone, and welcome to Cloud Native Live for today, October 29th. We're super excited to have you. In Cloud Native Live, we take the time to dive in behind all the technology that's in Cloud Native and get to kind of see like what's going on from the people who are actually building it and using it all the time. So before we go ahead and start, just a couple items of business. First, this is a CNCF stream, and as such, it is governed by the CNCF Code of Conduct, which basically boils down to be respectful to each other. We're really excited to have any comments or questions you have through the chat channels today. Just please keep those respectful and kind to each other. So the other item of business that we have, because we're coming up close to it, is time to make sure you're registered for KubeCon. We're coming up on that in just a few weeks. I'm actually local to the area, so I'm super excited for it this year, and I'm looking forward to having everyone here in the beautiful western edge of the Rocky Mountains. So make sure to register if you're interested. The link is displayed below. Time's running out to get those tickets, and they do run out sometimes. So make sure you're getting on there if you're interested. So with that, we're going to go ahead and introduce our speaker today, Luke, who's going to introduce himself, give a little bit of background, and start talking about the things he's working on. So Luke, go ahead.
Oh yeah, fantastic to be here, and thanks for the intro, Taylor. My name is Luke, CTO at Pulumi, and Pulumi, we've been working for a number of years on things sort of in the cloud infrastructure and space, and with Kubernetes and with the CNCF ecosystem, but primarily from the lens of kind of building infrastructure as code tooling, so letting you write code to manage your cloud infrastructure across both managed cloud services and Kubernetes. And I think over the last couple of years, we've started work on a new project, which we just released in general availability a few weeks back, called Pulumi ESC, that is starting to expand kind of towards secrets and configuration management, which is sort of this adjacent challenge that folks have, as well as kind of infrastructure management, is how do I get the sensitive secrets and configuration data into those infrastructure and application workloads. And so I think today we were going to spend a little bit of time just kind of walking through, playing around with Pulumi ESC, showing how it works and how it fits into both sort of application development generally and kind of in the Kubernetes ecosystem specifically.
Okay, that's awesome. So let's go ahead and get into it. So those who have seen this stream before, it's pretty demo heavy, and I already know, having seen a little bit sneak preview, that is exactly what Luke is going to do. So take it away, Luke.
Yeah, I think we're going to spend most of the time here kind of in code of some form or another. And I'll start, very, very basic here. And then we'll get a little bit more, we'll add a few more layers of complexity, and then maybe kind of wander around and just see some areas of the product. And of course, if there's any questions, happy to kind of answer those and direct the demos as needed. So my starting point for this, I have this list on the right, which is sort of a list of, maybe the security practices you may be given, or you may be sort of suggested to you around how you manage your secrets. And many of these are sort of, in some sense, obvious things, and yet also things that probably in a lot of scenarios, organizations are not doing as well as they could or should be. And certainly we've seen that many of these are hard for organizations to do. And so things like, not having secrets in plain text seems obvious, but a surprisingly challenging problem. And by this, I mean not just in your code, but kind of in your .env files, or sitting on your machine in plain text somewhere. Not having long-lived secrets that could be, if they get leaked, now I have to go rotate this large long-lived secret instead of having a temporary short-lived thing. Lots and lots of copy paste. We see this all the time, obviously, with secrets. That I have one environment, I need to go into one password, copy my password, put it into some local place where I'm storing it, and then I'll get to some of the rest later. But you can see these are sort of all things that that we may kind of want to be enforcing against the secrets that we're managing in our infrastructure. And so I have this little app here, and I'll kind of go through the stages of how we might kind of integrate some of these into our code. And so the starting point for my app, I actually, I didn't want to start with an actual secret in plain text here. So I have a fake secret in plain text here, which means, of course, my program won't even run. But, you can imagine this little app will tell a joke, and it should fail right now because Yeah, because I don't have a legal API key for OpenAI here. So, but you can imagine this might have been my starting point, right? I was writing this code and I just, hard coded my credential in here. That's obviously incredibly risky. We don't want to ever do that. And so what we can do with Pulumi ESC is actually go store this into a sort of cloud native secrets manager. And so I'll come over here kind of into the ESC product itself. And so we have a front end for ESC as part of Pulumi Cloud. And so here I am in sort of the Pulumi ESC environment section. And ESC stands for Pulumi Environment Secrets and Configuration. And so it's a secrets and configuration management tool that lets me organize my secrets and configuration into environments, which can be composed together. And so as a starting point, I can see I had this joke app environment here. I could just create a new one, but I'll start with this so I don't have to paste in the secret at all. We see here that in this joke app, we've defined an environment variable called OpenAI API key that has a secret value here. And of course, I could expose it if I wanted, but I'm not going to do that right now. I'll show you kind of what this might look like if I was to create one. I can say something like fake key, some secret, mark that as secret, say done. Save that, and now I've got my kind of environment variable set here. And so this is a very simple case of me just storing a secret directly within here. Now, one of the things to note about this is that these environments are actually, even though I have this table view here to edit them, they are actually just JSON or YAML documents here. And so you'll see that same environment variables and then the OpenAI key and the fake key, these are actually stored kind of with ciphertext that's encrypted with a per environment key. But the values here are just ciphertext for those things, and just placeholders for the fact that this is actually being stored inside kind of Pulumi Cloud's backend here. But regardless, I now have two secrets here that I can kind of access. And so one of the things I can do over here is change this to use a, I'll just pull up a little piece of code to copy in here. Just replace this with pulling it in from an environment variable. And so I could, of course, just set this environment variable locally on my machine. But as soon as I set this on my machine, now I have this long-lived secret sitting kind of in plain text in some form or another here. And so what I might want to do instead is take that environment that I just and let me just check what it was. It was called Luke/joke app. So I'm going to say ESC run upstarts is my organization, Luke joke app. And what this will, when I do ESC run, I can run any command I want, and I can run that within an environment where I've pulled down those secrets and injected them temporarily into that environment. And so if I run this, we'll actually see that it now ran the application. So we no longer hit that failure. We actually did inject an OpenAI key. And just to prove that this really is working, well, actually, I don't know if I may have set, there you go. So if I run this without that ESC run, you'll notice that this OpenAI API key wasn't set as an environment variable, so it returned nothing, and so this failed. And so I actually have to do this to inject the OpenAI API key into that. And so we can use this ESC run to kind of pull down those secret values, inject them in as environment variables into any command we might want to run. So this is useful for sort of operational tooling. It's useful for kind of anything we might want to get access to credentials. But it also allows us here to just write this application, not have to hardcode that credential, and do it within this environment. Now, that said, this in a sense means that I have to run this, kind of every time, and I can't just run my application. And so we kind of provide many different ways you could get this information into your application itself. And so, for example, I might want to use kind of an SDK to go access this. And so, grab some code which sort of does that. Actually, before I do that, I'll actually do one different thing. Even while I'm doing this as an environment variable, maybe I'll show kind of another piece of one of these steps, which is kind of these third and fourth ones here. So I have this OpenAI key, API key, but in the case that I just showed over here, we actually just hard coded it in here. But potentially, this is a situation where we actually have that key stored somewhere else, like potentially in AWS Secrets Manager, or potentially in 1Password, or some other source of truth, and we don't want to copy it from that system into Pulumi ESC. And so one of the things that ESC offers is, well, if you looked at this document here, I just had these values stored directly within here. But we actually offer a few different things that are interesting to look at, and I'll talk through these in this other example here, which is an environment, another environment I have called Joker, and it shows off a few other features of ESC that I'll speak about briefly here. So the first is that any one of these ESC environments, as well as defining values itself, can import from another environment. And so in this case, we're importing from the dev sandbox environment. And I'll just jump over and look at that for a second here. So I think that one is very interesting in and of itself. So this dev sandbox environment was one that is not specific to this application. This was built generally for me to be able to access my AWS credentials. And what it does, though, is it goes and uses OIDC against AWS to go get a temporary set of credentials that only last for 1 hour. And so here I've specified how to do that, and I've configured in AWS the OIDC configuration to say that it trusts Pulumi ESC to go capture local credentials for a certain role, given the permission to access this environment. And so what it'll do is it'll go log into AWS using this role in this region, and then it'll inject the outputs of that, like the access key ID, the secret access key, etc., into environment variables that I can then use kind of anywhere else. And so this is a handy way to just sort of automatically be able to go get some external credentials. I have support for quite a number of different OIDC based cloud platforms that we can go get temporary credentials for. But this allows me to not have to hard code any AWS credentials. And so when I'm going and pulling this value from AWS Secrets Manager, I can locally go get a short-lived credential, use that to go access things inside AWS, and then move on from there. But I'll come back here. So in this case, I'm importing this, which means I don't have to copy paste all that configuration. I'm just reusing that thing that my organization is sharing for how to access this dev sandbox account in AWS. But then for this application itself, I still need to get that OpenAI API key. And so to get that, I do two things. One is I use the AWS secrets function here to go pull some secrets out of AWS Secrets Manager. And so in this case, I'm going to use the AWS login that I got from this import, which has all my credentials. And I'm going to get this particular secret within Secrets Manager with this particular name. I'm then going to take that secret, and since it's just a string that's JSON encoded, I need to actually rip it out as a kind of parse it as a blob of JSON, and then get the OpenAI API key out of it. And so I can even transform the outputs of Secrets Manager by doing from JSON to turn it into an object, and then getting the OpenAI API key value off of that object. And that's obviously because Secrets Manager itself stores every value as just a string, and so you typically store things as JSON. And so anyway, this allows me to sort of then go compose a set of secrets that I want to inject into my application from the place where they live, which is inside AWS Secrets Manager. And the end result, though, is I still have an environment variable OpenAI API key. And so what that means is if I come over here and use Joker app instead of Joke app, I'm going to use that other environment, but that also specifies the same environment variable. And you see it still runs, and I didn't point this out, but we have a fun app here that every time we run it gives us a joke about some cloud infrastructure, just to make this a little bit more entertaining. But the point here is we were able to change that environment out. Instead of hard coding our credential, we were able to actually kind of go into AWS, pull out a Secrets Manager credential using a short-lived AWS credential, and use that to get the OpenAI API key. And so we've really accomplished sort of these first 4 goals here. By pushing that work out of the local machine, even out of Pulumi ESC, into short-lived access to a credential. And that only had to be in memory during the period of time while this Python program was running. So I see a couple of questions. Maybe I'll take this as a second to jump in and address those before we move on. So there's one about planning to launch Pulumi certifications. It's a great question. We have a whole bunch of training material. There's a Pulumi tutorials section we've added recently that has a bunch of sort of learning and training material. We haven't formalized that yet into a certification program, but definitely something that we get asked about a lot, and I'm sure is being planned. So if there's interest in that, I'd say reach out to sort of contact us on Pulumi.com or in the Pulumi community Slack. I'm sure folks would be happy to work with you and take your feedback on that. And then there's a question about recommended approach for syncing a large number of secrets from external stores using Pulumi ESC. How can we optimize performance, minimize sync delays in Kubernetes? Yeah, so I'll touch later on an example of kind of showing off things like external secrets operator and some other tools like that. I'd say there's sort of a few different directions that we'll kind of touch on here. One is in this particular example is me kind of dynamically pulling in those credentials when I need them. So, when this line of code runs to get the environment variable, I'm going to, well, when the ESC run happens, I'm going to go kind of pull those on demand, kind of just in time access them. But when we want to do this inside Kubernetes, there's obviously a few other things around the sort of pod lifecycle, and when am I going to go refresh those secrets? And that's where kind of tools like external secrets operator will help us, and ESC can integrate nicely with those. So I'll see a few more examples of that in a bit.
Yeah, and I also was curious, like, just to help summarize for the audience, who I know we always have a mixture who come and watch these, some who are new and to this, and some who aren't. I can see the differences, but I'm curious how you would answer this question. Like, what's the difference between something like this and then just using Vault or OpenBow or AWS Secret Manager directly? Because I know a lot of people have a lot of time invested into those. So what's kind of the main difference here, and that ESC is bringing to the table beyond those pre-existing tools?
Yeah, so there's some senses in which ESC has a lot of similarities to those tools, right? It provides the coarse granularity. It provides a sort of secrets and configuration management solution, kind of allows users to store their secrets and configuration in those systems. But a few of the things we just touched on are kind of exactly where some of the key differentiation happens. So one, kind of really, you can see sort of a more software engineering centric kind of solution. We allow sort of composition, right? So I can define an environment, reuse that across different environment, compose it in, so we don't have to do all the copy paste and management like that. We have the ability to kind of write these documents where I can like pull things dynamically out of AWS Secrets Manager, compose that into my things here. I don't have to use this as my secret store. So you can even, here we pulled things out of AWS Secrets Manager, but we could pull things out of Vault. So if we have our source of truth as Vault or as 1Password or as any other system, we can use this as more of an orchestration tool around our secrets. So we can compose things together, pull them from where their source of truth is, transform the values, and then present them back into applications or workloads as environment variables or other forms of data that they might need. And so you can really think about this as sort of a tool that can unify and sort of manage all of the secrets and configuration flows that you have, and combine those and ensure that you don't have to copy paste, you don't have to kind of move to one of those tools. So it fits really well into sort of a multi-cloud Kubernetes centric kind of workload where I might not need to have the same dependency. But if you're familiar with a HashiCorp Vault or an AWS Secrets Manager, you're going to see some similarities here for sure.
So basically it can do both, is what you're saying. So I could use this just as like my secret store if I wanted to, but I can also integrate in with any of the existing secret stores.
Exactly. And I think that's sort of the exact difference between these first two examples here is in this case, I'm using it as a secret store. I just have these values stored directly inside Pulumi ESC. But if I don't want to copy paste it into ESC and want to manage it, still inside AWS Secrets Manager or Vault or 1Password or wherever, I can do that. And sort of it's all transparent to Pulumi ESC.
Awesome. That's great. Well, we'll let you keep going because I think there's a couple other questions that have come in, and I have a sneaking suspicion you're going to basically show how this all works in just a second. So let's dive back into that and then keep the questions coming. We'll make sure we answer some more in a little bit.
Yeah, sounds good. I'll do the next part of the demo and then maybe come back to a couple of the questions, which may have been answered to some extent by then. So cool. So in this example so far, we've just relied on environment variables, and we've kind of relied on this ESC run, which means my application sort of can't run by itself. It needs to be sort of run within this context. And that's useful for many use cases where I might want to kind of take that application, embed it somewhere, or deploy it into Kubernetes where it is going to depend on some environment variables. But I may also want to actually bake, this code into the application itself. And so, for example, I can use the Pulumi ESC SDK as well, so that I can actually go run this directly within the code. So now I don't have to be dependent on ESC run. I can actually go out to ESC using the ESC SDK, and I can open and read that same environment. So here it's the Joke app environment, and then pull out its OpenAI API key and use that here. And so this means that my application itself now, and let me just try this. There you go. So it's running again, running still, but now it's running without me even having to do ESC run, because the application itself knows how to actually call out to ESC, pull in those secrets, and get access to the OpenAI API key. Now, when I'm running it here again, you'll notice that because I'm using the joke app, it's going and just using that static secret. But again, if I do Joker app, now my application is actually, when it's starting up, it's going to go out to ESC. ESC is going to get a temporary AWS credential. It's going to use that to go access AWS Secrets Manager and pull in this API key, and then it's going to bring it back into my application. And so all of that's going to be done and be auditable kind of from just from this simple piece of code here. So using the ESC SDK is a way to make sure my application can be sort of self-contained here. And so that's kind of a nice thing. Now, one of the things I should highlight is a few of the additional kind of features around kind of what ESC offers. And some of these also kind of go beyond what you might be familiar with in sort of Vault or AWS Secrets Manager. And they're more around how I can think about sort of versioning and sort of making sure I have an auditable trail of everything that's happening here. So one thing is, you'll see with an example like this, every time I want to sort of render a particular instance of this, you see I can click the open button here to actually go resolve the secrets. And so in this case, it went and, that did that whole handshake of going and getting a temporary AWS credential, going and pulling the AWS secrets, all that sort of thing. Now, by default, it shows me that these are secrets. So it's making sure we don't expose those back to you all on the stream. I could show secrets here to expose those, but by default, they're not shown here. You'll notice though, this ends with, well, funny, it ends with brute. But you'll see if I go hit this again, we're actually going to get a different access key because this was a fresh credential that we got from AWS. And so every time we open it, we're going to kind of resolve the logic of this environment and render back a, kind of a potentially new set of secret values. You'll also see here that we kind of have versioning of these environments. So we can go back and see all the different versions that we have had. So you'll see here, we added a password in line. We can go back through the whole history of this thing to all the different changes that were made. And so we can actually see at every different point, kind of what the different versions were. And so we can even diff across different versions here. And see all the changes that were made between revision 6 and revision 13, for example. And so this is really handy to be able to go back and audit kind of what changes were made, when were they made, what happened to this environment. A lot of these secrets managers, you modify the values and that's it, right? You've changed the state of the secrets manager. Here we have a whole history of every edit that's been made. You can revert back to one of these things. You can add tags to these revisions, that sort of thing. Now, the other thing that's really interesting about this is that these versions apply not just to being able to see the history of my environment, but also to being able to kind of come in. Well, actually, I'll come back to this one. So this was that dev sandbox environment. And you see it also has 2 revisions, kind of before we wrote it, and then revision 2. But let's say I wanted to make some changes to this, but they're going to change the behavior of my environment. And so that's potentially a breaking change to consumers who were importing it or using it somewhere. Well, there's a few options I can have. One is to just make it backwards compatible or give it a new name. But the other is I can actually come over in here and I can pin my dependencies to a specific version. Oops. So here I wrote @2 to mean I'm pinning this to version 2 of this dependency. And so now even if I change the latest version of that environment, this particular one is always going to use version 2 because it knows that it's sort of depending on the behavior of that particular version. And so this ability to pin versions to reliably roll out changes to secrets and configuration. This is another thing that many of the secrets and configuration managers don't do all that well today, surprisingly, is sort of manage the rollout and versioning of secrets and configuration. And so we've built that in very deeply into the model with ESC. And again, kind of embracing that notion of sort of a more software engineering centric approach to how we manage the definition and versioning of our secrets and configuration. The next piece related to that is sort of maybe the camera stopped for a second there, but let me just make sure the camera's all right here.
It's okay. We all have casualties of the equipment. There we go. Kind of. We're getting it solved.
Yeah. Okay. All right. Well, we'll switch to this camera. Okay. So yeah. So then we can come over here, for example, and if we come down, we'll see a few things. So one, we have the ability to sort of modify. I don't want to modify anything there. So we have a bunch of different teams. And so for every one of these environments, we can actually define certain teams, have members of those teams, and give them permission to access certain environments. And so Pulumi Cloud has its whole own sort of RBAC model where I can give teams ownership over certain environments or stacks or other things that Pulumi Cloud can manage. And so this allows me to make sure that obviously, having access to some of these environments is a very privileged operation, right? It means that by having access to this environment, I can go get that temporary AWS credential, or I can go get that OpenAI API key. And so in this case, we wanted to make sure that only these certain users have access to only certain environments. So we can lock that down kind of using Pulumi Cloud's RBAC. The other thing to note is, find it down here. There we go, audit logs. And so here we also see there's a full audit log of every one of the actions that's taken here. And so all these actions that were taken during the, well, actually, it looks like these are all some Kubernetes operator is actually going in and pulling these things. But you can see a lot of the different actions that were taken against our ESC are all audited here. So every one of the different actions that I might take within ESC, whether to edit an environment or to open it, are all being audited and logged there. So that I think is a great ability to go see exactly what happened against any of these things. All right. Well, let me pause for a second and answer some of the other questions that have come up here. So there's a question about how can we ensure that applications using secrets from Vault seamlessly transition to using ESC? Are there specific patterns or processes to minimize downtime or misconfigurations during migration? Yeah, so I think this is a really good question. So one thing, actually, I was going to show it later, but I'll just kind of maybe highlight it now very briefly. Actually, I think I have it. Maybe I have the repo open here. So one thing that we haven't actually kind of released this quite yet. It's still in a private repo, but going to be opening this up pretty soon. Is actually sort of a Vault proxy feature, and so this is the ability, kind of, if you're, if you have code which is dependent on Vault and on kind of having things within HashiCorp Vault, we can actually give you a proxy which will serve the Vault API, but let you then access those within ESC. And so I think this is a kind of a nice tool for helping with some of those migrations where you can keep your applications kind of consuming things via the Vault API, but still move that over into ESC behind the scenes. And so, for example, here, I can just run this little Vault proxy, and then I can just use the Vault CLI to consume that. So in previous examples, we were using ESC run to consume this, or using the ESC SDK. Here, we're actually using the Vault CLI, but we're still accessing, this is that dev sandbox environment that we saw. We're accessing just the access key ID because I want to try to not leak any actual credential here. But you see here, we're using the Vault KV store, but pulling this value in. And you see, again, we get sort of a temporary credential. Notably, even though this is using the Vault KV store, it's actually going and dynamically rendering those secrets. And so getting all those benefits of kind of pulling in these secrets on demand. And so every time I do this, it's actually going to get a different value because that's being sort of implicitly rotated every time. And so this is one of the tools we have to kind of help with migration. But of course, we can also have these things live side by side. You can continue to have values live within Vault or AWS Secrets Manager or wherever, and kind of just pull those into ESC and update applications or your infrastructure to project those into ESC.
So, we're getting a lot of interesting questions around like the day-to-day, like day two practices of implementing these things. Someone asked a
Yeah.
question around like they love the fact that it can be everything has short-lived, quickly rotated secrets. What happens in the case where they have to rotate the access key for Pulumi Cloud or any of like those bigger things that give them access to the other secret stores? What's kind of the process there? And um, I'm assuming that's being asked from an operational concern standpoint, like what's
Yeah.
involved.
Yeah, no, I think that's exactly right. So I think that's sort of talking about this line of code here, right? Where, we sort of had to bootstrap accessing this by giving this some credential. And so I think that's in a sense where, Kubernetes or sort of the orchestration platform beneath this is going to come in and allow us to, to sort of get this credential via some sort of workload identity model. And so I'll kind of show a little bit about that, but, doing that will maybe require, I'll show a couple of pieces of that. Maybe before diving into some infrastructure. So one of the other features that Pulumi Cloud offers is, and I'll go to see this, is the ability to kind of have OIDC issuers. So to be able to sort of access and get short-lived credentials for Pulumi Cloud itself based on some workload identity using OIDC. And so, for example, this is a case where I configured an EKS cluster that I have to be able to issue OIDC tokens, which can then be granted credentials. And so here we have, the decision to allow an organization token to be granted with standard privileges based on these conditions. And of course, I can add additional conditions to sort of, lock this down even more. But in this case, I'm allowing sort of, these particular conditions to grant this if they come from this particular OIDC issuer against this EKS cluster I have running. And so in general, we can use this to then get a Pulumi access token, rendered into every workload. And then instead of me in my ESC SDK, relying on the ESC access token, I can use that, the JOT that I have from OIDC on disk, use that to exchange that for a short-lived Pulumi access token that I can use to do this. And so that sort of allows me to bottom out on kind of workload identity within Kubernetes itself or within whatever other system. So that OIDC support can also work if I'm in my CI/CD system, for example, and I'm using GitHub. In fact, I'll just pull up. Let's pull up some of the docs there to kind of show, obviously lots of different integrations, but yeah, so here's GitHub, for example. Actually, this is not going to have the other side of that, is it? We support both sides of OIDC, which is the kind of the interesting, here it is, but this is the one. So here, if I want to configure this for GitHub, where I want GitHub Actions to be able to get a short-lived Pulumi access token and then use that to get into ESC and get my credentials, I can do that, using the GitHub thing. There's a docs on doing it with GKE. Obviously, what I was just setting up is EKS, which we're still working on writing up some docs for. But in general, we have the ability to sort of authenticate in and get a short-lived token using OIDC. I didn't set that up end-to-end, so in my examples, I'll still kind of run this way. But that is the sort of answer to where these bottom out.
Awesome. That was a great question from the audience. I think that's probably good for now, just so you can get to more showing more of this. And then if there's any other big ones, I'll summarize those in and answers. We can answer some more later.
Great. Yeah. Well, let me then kind of move over and I'll show this sort of running inside Kubernetes and kind of show a little bit about how that might work. So before I do, I'll actually take a slight detour and just talk for a few minutes maybe about kind of the other side of kind of what we do at Pulumi with our infrastructure as code offering, because the infrastructure I'm going to run this within is all defined with Pulumi here. And so in this case, I have an EKS cluster that I've stood up. That I stood up kind of using, these few pieces here. And this is defined using Python, but it defines actually a whole bunch of Kubernetes infrastructure. And it defines it in sort of that desired state infrastructure way that, you might with a Terraform or a CloudFormation or even with kind of Kubernetes YAML itself. But I can write kind of software to manage this and get, kind of IntelliSense and, type checking and all the other things you might want in this kind of case. And what I've done is I've actually sort of factored this out a little bit. So I created a component here, which is all of my base infrastructure. And so this creates, a VPC component, an EKS cluster component. It goes and gets a provider to be able to connect into that cluster. And then it actually goes and deploys a bunch of things into the cluster itself. Well, first creates an IAM role for my AWS load balancer, and then goes and creates a namespace inside the Kubernetes cluster, creates a service account for that, deploys the AWS load balancer Helm chart. And so you can see sort of with Pulumi ESC, we're able to sort of coordinate over a whole bunch of things inside the cloud itself, things inside the Kubernetes cluster, even kind of deploying Helm charts, all in sort of a strongly typed, componentizable software-based way again. And so this is all kind of how I went and did that. In this particular case, I'm sort of going and taking a secret that I have here and storing it kind of inside a secret within the cluster. And so this is the piece that I would not do once I had the sort of OIDC configuration set up. But for now, I just have this storing that into the cluster as a Kubernetes secret. The other piece to this is then the service deployment. And so this is just sort of taking the common pattern we might have of creating a deployment in a service and exposing those. We obviously copy paste this YAML around all the time. There's a lot of boilerplate in here. But in this case, we just defined a little kind of helper class in Python that goes and takes a few kind of parameters here. So, these are all the parameters we support, and then just renders those into a deployment and a service here. And so you use Python to sort of construct these and build the sort of software around this, but then ultimately just expose a simple interface here where we can just provide a few things. And so this is running kind of nginx inside this cluster. And so we have this running, assuming we haven't gotten logged out of AWS here. We'll see that, this is all kind of running inside here. And so if I look at my services, I've got the, the app, I think this is called app, yeah. And this is that service running. We've got the load balancer URL here. And so assuming this is still working. I don't know why that's taking a while, but I think it's the same one that's right here. So this is the nginx server kind of running within AWS now within that EKS cluster. Now, the thing I wanted to kind of do, I'll show off two things here. One, I'll show off kind of external secrets operator, just to give a sense. So Pulumi ESC also kind of works with external secrets operator, which would allow me to then go not have to change my code to depend on any secrets. I can just have environment variables that I depend on, and external secrets operator will take care of reaching out to ESC, going and pulling those secrets in, including pulling in that dynamic rendering of secrets, and then storing them in as environment variables that I can expose into my pods. And so ESO has support now for Pulumi. And so, for example, we can see what we did here to install that. Created a new namespace for external secrets, deployed the external secrets Helm chart, and then created this secret here. The ultimate place we use that, though, is inside here. And here, as we did a few things. So one, we created a cluster secret store that knows how to point at the same place that we were looking. So my Pulumi organization, and this is the piece that's new with the external secrets operator support for Pulumi. We can point at our organization, our project, and then this environment ESO demo. And then we can use the Pulumi access token here to access that. Now, this is the piece, again, we would replace with kind of the OIDC configuration once we had that set up. But if I come over here and look in my environments, we have this ESO demo, and it has sort of two secrets here, app.hello and app.hello secret, which are a plain text and a secret value. And so we can take those two values and sort of map them into a deployment or a pod or anything else like that. And so in this case, we have a Helm release of the pod info pod. And we're taking, we're injecting some extra environment variables. So here we have two environment variables we're specifying, and you see they are this hello secret and hello keys that we just looked at inside ESC. And so we have this running as well over here, and I'll just bump up the font a little bit. And so you see that when I run this, I have those two environment variables running inside this pod, and they're pulled now from ESC, but via external secrets operator. So I have my code itself. This is not any code I control at all. This is just the pod info standard Helm chart and Docker image. And it just exposes whatever the environment is. But in this case, I got those into the environment indirectly just via the ability to pull credentials from ESC. So kind of nice to be able to integrate end-to-end from something like external secrets operator all the way into this. And then I guess finally we kind of had the external secret that maps between these two that lets me pull from the external secret store and sync that on a regular basis. So that's I think one key part of this is being able to use something like external secrets operator to get my secrets in reliably to Kubernetes from ESC. The other piece, though, that we may want to do is something like this piece down here. And so this is actually taking that original app that I wrote, that joke app. I'll actually come over here maybe and show what I did to build this. So here's that same code that I had before. And again, kind of only dependent on a Pulumi access token, but otherwise just pulling things out of ESC. And this is just in a joke.py file, but now I have a little HTTP server that is just going to use that function tell joke and render it as a H1. And so then we have a Docker file which just builds this, and we built and pushed this image. So let's rebuild it here to show. And so we push this into Docker Hub, this Luke Hoban / Joker image. And so now I can grab this out of Docker Hub. It's going to expose port 80, just like we saw in the code. But in this case, it's going to be pulling that code at runtime kind of from ESC. And so here we have that running at another endpoint within our EKS cluster. And so every time I refresh this, we see it's actually going to render a new joke. And so here we have those jokes coming up every time, but again, being rendered via dynamically pulled credentials for accessing the OpenAI service. And so this again is sort of just another way of showing how this can end up inside Kubernetes with an application workload, the same workload we were running kind of from the beginning, but now kind of running inside our Kubernetes cluster using all those pieces of infrastructure. All right, so that's probably a good place to pause and see if there's any questions, and then we can come back if there's not.
Yeah, one that I think I've seen some of this through some of the questions that have been asked, and also something I've been curious about is, what are some of the use cases you've seen? I mean, obviously you're probably dogfooding this internally at Pulumi. Have you seen other use cases out in the wild of people using this where they've leveraged it, especially because you have integration across the whole cloud native stack? What kind of value are people getting out of it? What are some of the more powerful use cases you've seen, just to kind of help people understand where it might fit into their day-to-day?
Yes, I mean, I think one of the, there's been so many different use cases. One of the things when we started with ESC, it was really initially to solve the problem that we had kind of around infrastructure as code secrets. And so, for infrastructure as code, this is one of the places where you have some of the most sensitive credentials in your system, are kind of your AWS production credentials, your Kubernetes cluster, kube config files. And so we had to build a bunch of support for, hey, how are we going to securely managing getting credentials and secrets kind of into your infrastructure as code? And so I'd say a lot of our early use cases for ESC have been around kind of helping folks to manage those better for Pulumi IAC, right? So for the Pulumi infrastructure as code. But I think as part of solving that, a lot of the things we talked about here around sort of composable environments and dynamic short-lived credentials and being able to pull credentials out of other sources of truth, we saw that these were needs kind of for a lot of use cases, right? These weren't just for infrastructure as code. These were just as applicable for application workloads or operational tooling or other sorts of things. And so I think one of the things that we've been So I think in some sense, the answer to your question has been a lot of the really kind of powerful use cases have started with infrastructure as code and been people really taming a lot of complexity in how they get secrets and configuration in there. But we've then seen people grow out of that into a whole bunch of much more sort of dynamic use cases where they're, kind of building a whole bunch of operational tooling, or developers no longer need to have .env files or any static credentials on their machine. They're using ESC run. They're using the SDK embedded into their applications. And so, for example, we use this, very heavily ourselves, kind of within the Pulumi organization. Pretty much every developer now kind of uses this as the primary way that they get short-lived AWS credentials into our various demo and production environments. That we, kind of all of our production infrastructure is kind of using ESC as a way to get secrets into the infrastructure instead of having to store those in some other system outside of ESC. So I think lots of exciting kind of places we see this being used, and just the flexibility it provides for developers, I think is very attractive.
Awesome. Another thing that I noticed is you had a fair deal of integrations. Like I just looked at the doc site before we came on here, and then also just showing here you integrate across a lot of things in the cloud native space. What other well-used tools or also CNCF things do you integrate in with that people would be interested in hearing about, or even ones you might have planned for the future if they're coming up soon?
Yes, I mean, in answering the second question first, I mean, I think we're definitely excited to integrate with just about anything, right? I think one of the core goals we have is to be a very horizontal tool that both from a sources and a targets perspective. So what can you pull into ESC and kind of consume and compose over, and then kind of where can you pull that? Where can you use those secrets? So how can you kind of pull those secrets into other environments? And so here we have a variety of the things we support today. So we support kind of OIDC and getting short-lived credentials from a variety of different sort of cloud and SaaS kind of data stores with the major clouds and Vault. We support pulling then secrets dynamically from a variety of different secrets stores, including 1Password. Also things like Pulumi Stack. So I might actually show this as sort of kind of a last demo in just a bit, but also pulling secrets that maybe I provision some infrastructure, like I provision a Kubernetes cluster. It exposes a kubeconfig file. That's a really sensitive secret, associated with my infrastructure that Pulumi ESC knows about. How can I then go consume that from an application or from another piece of infrastructure? And so this is a useful one as well. But then you can kind of consume ESC from an even wider variety of different kind of platforms, and that's kind of some of the things we've shown today. We've shown consuming from Kubernetes. Using external secrets operator, using a number of other tools. I'll show for example, just the Terraform docs, right? So, even if you want to use Pulumi ESC with your Terraform code, you can do that. And, here's an example of sort of an environment where, again, we kind of get a short-lived AWS credential here using OIDC, but then we expose that both as the AWS credentials we need, but we also expose these TF-var variables. And so Terraform knows if there's any TF_var_ environment variables, it will kind of turn those into Terraform variables files that are inputs into my Terraform apply. And so if I have this kind of thing defined, I can ESC run a Terraform apply, and it'll actually, the instance type, which I assume here was set to a variable. Yeah, here's the variable instance type. That will be set to, kind of t3.small, because that's what I specified in my ESC environment. And so with ESC run, we can sort of integrate into something like Terraform, similarly kind of the var file use case here. Actually, this is something I didn't talk about before. We talked a lot about environment variables, which lets me inject things into environment variables within a process. But ESC run actually also supports a files property. And so if I specify files, ESC run will actually write a file into the local environment that I can then, it'll give me this environment variable here, which is bound to the file. And so this is a way to sort of dynamically create files as well that may have my secrets inside them. So that if my applications depend on a file existing, I can kind of use that. And so in this case, it's going to create a file, that has these values inside it as a JSON document, and it's going to store it inside this environment variable. And now I can kind of just move that to where I need and Terraform apply with that file. So kind of a nice, additional sort of composition technique we can do. We are looking here at building our own Terraform provider, for example. So in the future, we expect to have just a Terraform provider so that within your Terraform code, you can pull in ESC, kind of like the ESC SDK. But we already have good support for this here. Go back to I'll go back to the integrations page. So that was the Terraform one, obviously kind of integrations with a number of these other ones as well. And then of course for syncing, this one, I don't have a demo prepped, but I think this one's really interesting as another use case. So, here's an example of pushing my ESC values into GitHub secrets for GitHub Actions. And so in this case, I'd set this up and configure it so that on a given schedule, or whenever an update is made to one of my ESC environments, it's actually going to push the values from that ESC environment out into GitHub secrets so that I can actually keep my GitHub Actions secrets up to date without having to manually copy paste in there. Instead, they're actually getting updated on the fly whenever they need to be via ESC. And this even works with our dynamic credentials. So with, kind of the short-lived AWS OIDC credentials, we can still set it so maybe I get a 1 hour token from that, but this is set to sync every 30 minutes. So that now every 30 minutes, I'm getting a fresh kind of AWS credential pushed into GitHub secrets so that my GitHub Actions can kind of consume those directly. And this we've seen a lot of interest in because it sort of avoids one of the other big classes of where I have to copy paste these long-lived credentials and store them in some other system other than their source of truth. And so the ability to sync into things like GitHub secrets, but also into AWS Secrets Manager or into HashiCorp Vault is a really exciting thing as well. Like I said, one very last kind of thing I might show off just to kind of see a little bit of this more end to end. And I'll just start off in a terminal here. But I'll actually just show this is effectively highlighting kind of this integration here that I mentioned, which is sort of using secrets out of the outputs of a Pulumi stack. And so I might want to do like Pulumi new, grab a template. I'll create a Kubernetes thing with TypeScript. Let's call it test. So this is going to just create a new Pulumi ESC program. And actually, yeah, so I'll just open this up in a new terminal here. Not sure why that's not opening up. Oh, there it goes. There we go. Okay, so bump up the font a little bit. So here we have, kind of a new IAC application. This is just going to deploy some Kubernetes infrastructure, but I want to make sure that this is actually going to deploy into the right Kubernetes cluster. And so I want to, in a sense, use that Kubernetes cluster that I had created in that other application. And so one of the things we can see here, I had created beforehand another environment called cluster. And this is using that Pulumi stacks function. So this is actually going to grab the infra/demo Pulumi stack, which is the one we were just working on that defined our EKS cluster. It's going to grab its kubeconfig output and to JSON it, and then it's going to put it in some Pulumi config for the Kubernetes kubeconfig value. And so this environment, like if I open this up, will expose this kubeconfig as a config setting for Pulumi ESC, which is exactly what I need here. So I can do Pulumi config and add. And what was the name of that? It was Luke/cluster. And it tells me now, once I add that environment, it's going to now see that kubeconfig because that was one of the outputs of that environment. And so now I've kind of bound this application I'm deploying to that cluster via that environment, which just knows how to pull that out. And so now if I run Pulumi up on this, we'll see that it's going to actually deploy. I'll just go ahead and say yes to deploy it. It's going to deploy this Nginx deployment into our cluster. And so we should see, if we were to come over into here, we should see in the default namespace now, this Nginx just a few seconds ago. So we deployed that into this same cluster, but we did it by pulling the credentials for accessing this cluster out of ESC. And this again sort of highlights, I think throughout this demo, we've never really had to store any long-lived credentials on our machine locally. All of this was sort of done dynamically by pulling things out of ESC. I think that's it for kind of demo walkthrough. So I'll see if there's any other questions here before we kind of wrap up.
Yeah, awesome. There's I think just my thing that I would like to ask is like the whole call to action. Where should people go to? Like what should people try out? Like where are you looking for ideas or feedback or help or any of those things?
Yes, I mean, I think we're always interested in folks just taking it for a spin. So you can go into the Pulumi ESC docs. There's a getting started guide, some good tutorials, and of course integrations and highlight for all the things we kind of talked about here. I'd say if there's scenarios where folks are kind of interested in using ESC, but they want a new integration, or maybe they're interested in working on an integration with this, definitely reach out to us in the Pulumi community Slack. I think it's linked up here. Yep. So if you join in the Pulumi community Slack, there's an ESC channel in there. You can dive in with questions, comments, thoughts, things that you'd like to help us with here. Always eager to get contributions or community engagement on this.
Awesome. Okay. Well, I'm not seeing anything super. Were there any other last closing things you wanted to leave with people before we wrap up here?
No, I think that's it. I mean, I think the highlight is really kind of, I think with Pulumi sort of been known generally within the ecosystem here for kind of the infrastructure as code piece, and continue to kind of be doing a lot of fun stuff. We touched on a few things there in the infrastructure as code side, but I think with ESC, we really think that bringing that same kind of software engineering approach into how we manage secrets and configuration is a huge opportunity. And I think coupling that with kind of some of the other CNCF projects and Kubernetes that we integrate with here, I think is a really fun way to manage your secrets and configuration across all of the different environments and clouds you're working within.
Awesome. Well, I just want to say first off, thanks for coming today, Luke. That was a great discussion. We showed all the resources on the screen, and you can always come back and watch this recording later if you want to grab those again. So go try things out, give feedback, and thanks again, Luke, for coming on and joining.